The design objectives and goals are to have our paddle juggle a puck stably and continuously for over a minute on an air hockey table that is inclined to 60 degrees. We also must use the PlayStation Eye camera to track the location of the puck constantly. The system should also be removable without damaging the table. This is the 3D model of the structure built using AutoCAD. It holds the motor firmly in place while still being removable. These are the mirror law equations used to change the angle of the paddle based off of the puck's x and y positions and the puck's velocity in both respective directions. It uses this data to calculate the energy of the puck and feeds it through the shown equations, making adjustments to how hard it hits the puck. This video shows how the paddle responds to the puck's change by mirroring its location. Notice how the paddle moves up and down in the opposite direction of the puck. The maximum angle was limited to 60 degrees through saturation. This prevents the angle from becoming too steep, which in turn would take too long to move back to 0 degrees. The paddle also switches its orientation depending on which side of the board the puck is on. Seen here is the vision code output windows. Notice how the command prompt begins to display the puck data as soon as the puck comes into view. The software uses hue saturation value filtering to obtain the green value from the image and then finds the center point. If you look closely, you can see that the code then draws a blue box around the center of the puck. HSV thresholding was the selected method of filtering because it allows us to put our hands in the frame without issue. Background subtraction, the other alternative, does not allow for this, and the testing process is much more tedious as a result. This is the Simulink model of our system. Located at the top left is a UDP unpacking box. It puts x and y position and velocities from the vision code into an array. Then our array goes into a scaling block which applies a look-ahead function to account for time delay. We then use a multiplexer to select which juggling program to run. There are individual function blocks for trial mirror law, back and forth, regular mirror law, revised mirror law for left and right, and the rocker function. The motor angle is sent into the PD controller for the encoder motor. This is our revised mirror law juggling on the left side of the table. As you can see, the arrow points to the desired height of the juggle. This is set using the eta function. We had to revise the mirror law because the normal mirror law's X position correction isn't satisfactory. If the gain is set too low, then the system can't move the puck back onto the correct side of the board. If the gain is raised high enough to get the puck onto the correct side of the board, it won't be able to reach a stable juggle because the X correction will be too sensitive. For the revised mirror law, the major X correction is hard-coded to move the puck onto the correct side of the table. If the puck is falling, the paddle goes to 0 degrees to stop the bouncing and prevent the puck from falling below the paddle. The paddle then raises up to roll the puck to the right side. This allows us to use a smaller X correction gain to produce a much more stable juggle. The model displays the set point of the motor position, and the error signal. The error signal is also plotted. The eta, or energy of the puck, is graphed along with the positions and velocities of the puck. This juggling program uses the same revised mirror law as left side juggle, but the hard-coded X correction is on the other side. The gains are slightly different on the right side due to differences in the table friction. This trick is called the rocker. It uses a closed-loop system that tracks the location of the puck on the paddle. According to the puck's location, the program tells the paddle to rotate to -50 or +50 degrees. We use a rate limiter to slow the speed of the motor so that the paddle will roll the puck and not launch it up. This is the back and forth trick. This trick changes the desired X position of the puck to the opposite side of the table. The puck must juggle stably to a certain height before the system will send it to the other side. This is to ensure the puck has enough energy to make it to the other side of the table. Look at me, I'm all the way turned up. I ain't smoking, but my homie in here burnt up.
It was mighty interesting, but I tell you one thing, it looks like it needs to be quicker. Quick, 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 quick. No one likes a slow person. No one. Remember that.